Section 7.4 is today, and it is a short section with a mere 4 examples to do with this section. And what we're going to do is solve equations that are quadratic in form. Okay, so that means that let's look at our first objective. Our first objective is to solve equations that are reducible to a quadratic equation. So let's start with saying, well, what's a quadratic equation? And if you remember, it is an equation where the first term is a power of 2. All right, so I could say x squared plus 3x plus 2 is a quadratic equation, provided I put an equal sign there equal to 0. All right, so here we've had some experience with this already, but this is a quadratic equation. My first term here is x to the second power. Now, if I get something that's quadratic in form, and here's what we're going to encounter in this section. If I have something like x to the fourth plus 2x to the second plus 1 equal to 0. Well, this isn't to the second power, this first term. It's x to the fourth power. But I could conceivably rewrite that. So it's something to the second power. And the way I would rewrite that is I could say this would be rewritten as x to the second power raised to the second power. Okay, then I've got something that is raised to the second power. And the something is x to the second power. So given that, then I've got plus the 2x squared plus the 1. That equals 0. Okay, now if you look at that, here I've got the x squared. My middle term is the x squared, and that's another key feature that we want. We want them to be the same. And that's where you can get it from, actually, without having to do the first part here. Okay, so getting back to my point, I'm rewriting this x to the fourth equation as x squared raised to the squared. Okay. Another one may be, and this is a bit challenging, this would be x plus the square root of x. Oh, that's a minus. Let's make this a minus. Minus the square root of x and minus 12, just as another example. Okay, I'm looking at this x, and how could I write that in terms of being raised to the second power? Well, I could take the middle term here and make it the square root of x, put it in parentheses, and square it. And now this first term is something raised to the second power, and that something is the square root of x squared, which equals x, so it's the same thing. I just rewrote it in a different form. Minus the square root of x minus 12 equals 0. All right, once I get that in my proper form, with this being to the second power, then I can start factoring that, which invariably is what we're going to do. All right, so that's example 1, example 2, example 3, and that's basically it. If I had one more example here, would be if I had a problem with x minus 2 raised to the second power minus 3 times x minus 2, and maybe minus 10. That equals 0. Okay, this is quadratic in form. My first term here is something, so it happens to be a binomial raised to the second power, and that's okay. If I wanted to factor that, I could say what? Here's my 2 binomials where it comes from, because my lead coefficient still has a coefficient of 1. So x minus 2 would go here, and x minus 2 would go here. I copy my signs down, and then what would I have? I need 10 and a negative 3, so I'd have 5 here and 2 here. Okay, I'm not worried about the middle term. That's when you multiply it together. So this is it, equal to 0. Now I can say this is going to be x minus 7, and this is going to be x minus 4 equals 0. Okay, then you can get your answer from that. So finish that up. All right, so let's do some problems, and in these examples, let's try it out. Okay, here's our first example, and you can see I've got a quadratic equation, but I have these binomials in place of the single variable of probably x, that we use that all the time. So I want to look at this differently, though, and I want to make it a little bit easier. Okay, for some of us, it may be easier if I use a little bit of substitution to get this back to the familiar ground that we're accustomed to. So in other words, I'm going to look at this and I'm going to say, well, if x, not x, I'm going to say if y equals x plus 3, then I could replace the x plus 3's in this problem with y. Okay, y equals x plus 3. So let's see. So in other words, this is going to be y. Let me change my color. Y squared minus 2y minus 8 equals 0. So this is in the same form. Y equals x plus 3. So now I can factor this in my traditional way. All right, so let's go back. Lead coefficient is 1, so that's the easy one. And fill it up with a y here and a y here. My signs would be minus and plus. And then my two values are going to be, let's see, I need a negative 2 in the middle. It must be 4 and 2. That makes it equal to 0. Okay, so here I am now. Now I could say for this one, when y equals 4 satisfies this equation, and for this parentheses here, y is going to equal negative 2 to solve for y. But we're not solving for y, we're solving for x. So now I got to replace the value of y in for these two equations. And we said earlier that y equal x plus 3, for clarity's sake only, to make this factoring a little bit easier. So if y equals x plus 3, I'm going to put x plus 3 equals 4, and this one, x plus 3, will equal negative 2. And now I can solve each of these for x. So here I'm going to subtract 3 from both sides, so x is going to equal 1. And this one here I'm going to subtract 3 from both sides, and x is going to equal negative 5. So these are my two solutions. When x equals 1 and when x equals negative 5. And that's how it's done using what I'm going to call substitution. It's actually called use substitution, so I'm going to replace that with use in my remaining examples. Okay, let's go on to our next one. All right, how about this problem here? Okay, I can see I've got an x to the 4th here. I want to rewrite this to be in standard form, so I could start by subtracting 2 to both sides. So let's see if I have 4x to the 4th plus 7x squared minus 2 will equal 0. Okay, that's a good first start. And now I see my first term here is x to the 4th. Alright, so what I want to do is I want to say, this time I'm going to call it u equals, let's see, how can I rewrite this? I could rewrite it 4x raised to the second power raised to the second power. That's 4x to the 4th as well. So my what's inside the parentheses is x squared. So I want u to equal x squared. It's good to figure this out and kind of understand that, but really where we're getting our value for u is right here. Whatever is there as the middle term. Okay, so this is just the variable now we're working. So if u equals x squared, I'm going to rewrite this problem to be, and I'm going to erase this. Okay, I'm going to erase that and put 4u to the 4th plus 7u minus 2 equals 0. Remember, u equals x to the second. So if I replace this u with x to the second, it would match what's up on top here. Simply put. Alright, so now this is what I've got to use to factor. Here I've got to use the grouping method. 4 times negative 2 is negative 8. 2 factors of negative 8 that give me 7 would be 8 times negative 1. Okay, if that's 8 times negative 1, I'm going to rewrite it. And let's be able to say 4 u equals so here I've got I'm looking at my previous work here. This is not right. Let's get rid of that 4. That should be 2. That was it. Let's make that a 2. Because u equals x squared. So that would make it x squared raised to the second power, which is x to the 4th. So this is what I want, not 4u to the 4th. Alright, so I've got, I'm rewriting it now, so it's going to be 4u squared plus 8u minus 1u minus 2 equals 0. Okay, then I know I'm going to group them. Having done this for quite a bit of time here now for all of us. Okay, and now factor the left side. So 4u comes out, and what's left is u plus 2 minus, on here, 1 comes out, and I'm going to have u plus 2 equals 0. Take out the u plus 2. And what's left is 4u minus 1. Okay, equal to 0. So, keeping on going here for solving this for u would equal negative 2, or for this parentheses, u is going to equal 1 over 4. However, we're not solving for u, we're solving for a different variable called x. So now I've got to replace the u with x squared to reach my final answer. So this would be x squared equals negative 2, and this one, x squared equals 1 over 4. And now we'll solve for x. So one answer, I'm going to square root both sides, so x is going to equal plus or minus, let's see, I root 2. There's a square root of negative 1 times 2. And that's one answer here. It's imaginary. And for this problem, x squared equals 1 over 4. So see, that means I'm square rooting the left side, so x is going to equal square root of 1 is 1, square root of 4 is 2, and that is going to be a plus or minus in front of it. Plus or minus. Let's see if I can make that right. Okay, and in this case here, we have 4 solutions. So here I got plus or minus I root 2, and this is x equals plus or minus 1/2. 4 answers as indicated to us by the original problem where it's x to the 4th, which is telling us we could have up to 4 problems, 4 solutions. Okay, that was example 2. Example 3. All right, here's example 3. And this one's a little tougher when we are solving problems. And again, you know, I could use the square root property here to solve this as well. As a matter of fact, I'll do it 2 different ways. Okay, so so you have 2 weapons instead of 1. If you forget that first one, what to do and all that, you'll get the problem wrong. But you can always rely on the backup plan for this. There's always more than one way to skin a cat, as they say. All right, so for this one, however, I'm going to take this middle term, that's square root of x, and I'm going to square it, and that's all I've got to do. I'll put this in parentheses too to emphasize. Okay, and then I'm going to rewrite that to be plus the square root of x minus 6 equals 0. Okay, so now I can look. I don't want to deal with that square root of x. If you didn't want to deal with that square root of x, then you could say that u equals the square root of x. And then I could rewrite this problem to be u squared plus u minus 6 equals 0, because u equals the square root of x. Okay, now I've got it in this familiar form, which is my intent in all these problems. And then I'm going to factor this. So again, easy factoring, where I got u and u, plus and minus, and it looks like I'm going to have 3 and 2, all equals 0. So in solving for u would equal negative 3, or u will equal 2. And then I got to replace the u with its original value. And we said u equaled the square root of x. Well, if u equals the square root of x, then the square root of x equals negative 3, and the square root of x equals 2. All right, let's solving for x now. So in this case here, I have to square both sides. I'm going to square both sides. And when I square both sides, that means I have to check my answer for what's called extraneous solutions. Okay, so let's see. This is going to end up being x that equals 9. And if I square both sides here, I'm going to get x equals 4. And this is what I have to plug into my original equation to see if which one's right, and maybe an extraneous solution for one of these as well. So 9 and 4 is it, huh? All right, so let me come up here. Here's my original problem. Okay, and I'm going to try 9. I'm going to put in 9 here for this. So that would be, let's see, I'll use red. So 9 plus the square root of 9, because we're getting 9 from down here when x equals 9. So that's why I'm plugging that in up here. X equals 9. So then I'm going to subtract 6, as that equals 0. Alright, 9 plus the square root of 9, which is 3, minus 6 equals 0. Well, 9 plus 3 is 12, minus 6 is 6, so 6 equals 0. So that's false. So that is no solution. Okay, no solution for that one. If I go ahead and try out 4 for my other answer, this is here, and plug that in, then let's see, I can do it here, I think. Let's see, mark it off here. So that would be 4 plus the square root of 4 minus 6 equals 0. And let's see if that's true. And if that's true, we're in good shape. So then I got 4 plus the square root of 4, which is 2, minus 6 equals 0. 6 minus 6 equals 0. And 0 equals 0. So 4 is a solution. So this is a solution. X equals 9 is not a solution. And how did I know to do that? When we're squaring both sides. When I have a radical, in other words, and I'm squaring it to get it outside the radical. You know, I have to do that to the left side, but you also have to do it to the right side. But whenever you do that, you have to plug that in. Okay. Okay, before we move on, I want to do another example similar to example 2, only it's the, what they call these practice problems that are on the margin of our pages in our textbook. Okay, so without too much talking, I want to go through and do this. Alright, so what does this mean? Here's my problem. I want to get it in standard form first, so subtract 5. So that means I'm going to have 6x to the 4th minus 13x squared minus 5. That equals 0. Okay, I want to do u substitution because I can see if u equals x squared. U equals x squared, and it's right there in the middle term. The variable of the middle term is what we're getting it equal to u. Alright, so when I rewrite this now, if u equals x squared, this is really 6x squared raised to the second power. So you can see if I substitute the u for the x squared, this is going to end up being 6u squared minus 13u minus 5 will equal 0. Okay, so I'm changing the variable to u, and I'm solving, factoring this trinomial, or solving this quadratic equation. Alright, so let's see, what do I do? This is a grouping method problem, so 6 times negative 5 is negative 30. 2 factors, that'll give me negative 13, and it's going to be negative 15 times 2. Okay, when I rewrite the problem, I've got 6, what I've got here, 6 u squared minus 15u plus 2u minus 5. That equals 0. Okay, let's group them. And here I'm going to take out a 3 and a u. Between 6 and 15, I take out a 3. Okay, and what's left is going to be 2u minus 5. Bring down my plus sign. I can only bring out a 1 here, and what's left is 2u minus 5, all equal to 0. Alright, take out my binomial factor of 2u minus 5, and what's left is 3u plus 1, equaling 0. Move it up. How about solving for u now? So in this one, u will equal 5 over 2, and this binomial here, u is going to equal negative 1 over 3.
They're making food!
Okay, we're not solving for u, we're solving for x. So I got to go back up here and remind myself that u equals x squared. If u equals x squared, then this is going to be x squared equals 5 over 2. And on the right side, I'm going to have x squared equals negative 1 over 3. Okay. And now let's take the square root of both sides here. And when I do, I'm going to have x that equals the square root of 5 over the square root of 2. Okay. I have to rationalize that denominator. I can't have a radical in the denominator, so I'm going to multiply it by the square root of 2 over the square root of 2. And that's going to then give me an answer that x equals the square root of 10 over 2. And that's plus or minus 2 answers. Okay, that's for this side here. And then I'm going to do the same thing here. I'm going to square root both sides. Notice I'm breaking them up into the pieces and the fractions. So this is going to give me square root of x squared is x. That equals, well, here's the square root of negative 1. And that equals I. And that's going to be over the square root of 3. Okay. Then I have to rationalize this denominator. So that means I want to multiply top and bottom by the square root of 3 over the square root of 3. And that's going to get me an answer of x equals plus or minus, looks like I square root of 3 over what? 3. And there's my second answer. Okay, and that checks, and that's good. All right, that's a little bit more clear as to what I was doing in that from that previous example too. All right, now we got a couple story times to talk about. I'll be right back. Alright, here is example 4. Not bad, but a little tricky. And here it is with this application problem. If an object is thrown into the air with an upward velocity of 12 feet per second from the top of a building, h feet high, the time it takes for the object to hit the ground below is given by this formula. Okay, that's 16t squared minus 12t minus h, that equals 0. Okay, so this is what we have to work with to basically factor this. Alright, we don't have a value for h, but we're going to use the h as part of our answer. Alright, so what am I trying to say here? Let's see, I've got I'm going to write this out. 16t squared minus 12t minus h. That equals 0. Alright, so let's use the quadratic formula this time. Alright, so if we do, then a is going to equal 16, b is going to equal negative 12, and c will equal negative h. Okay, and that's the part that's a little bit odd about this problem. Alright, let's fill it in and see what happens here. Okay, how about, what is it now? Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. As a reminder. And then we'll fill this in with our values. Alright, a is 16, and negative b is going to be negative 12. So b will be 12 plus or minus, then I want the square root of b squared, which is 144, minus 4 times a, which is 16, and times c, which is negative h. Okay? And that's all over the 2a. And that'll be 32 is going to be my denominator. I'll remember that afterwards. I like to figure this out first. Alright, right side here I've got negative 4 times negative h, which is positive. So that's going to be here, square root of 144 plus, what did I say that was? Negative 4 times negative h is positive 4h times 16 will be 64h. Okay, these are unlike terms, so I can't add them up. And I can put this 12 here, plus or minus. All over, this is going to be 32 now. Okie doke. And what about it here? What can I do with this? If not anything. Well, over here I can do something with under the radical sign. Let's see, I want to simplify this a little bit is what I want to do. So let's see. If I take, so 1/2 of my problem is going to be 12 over the 32. And then I'll simplify that. Then it'll be plus or minus. Now I've got to figure this out. And under the radical I've got this 144 plus 64h. And I want to factor something out of there if I can. And it looks like maybe I could take out a 4. What could I take out of there? I'll start with a 4. I'm trying to think if there's something bigger. 12? Not quite. Alright, let's start with 4. If I take out a 4, then 4 into 144. What is that? 24, 4, that's 36. Okay, if I take out a 4, for here now I'm talking, these two guys here, I'm going to have 36 plus, and 4 goes into 64, 16 times 16h. Okay, I could keep going here. I could take out another 4. Looks like if I take out another 4, that'll make this 4 16. And then, remember I'm talking about 4. 36 divided by 4 is 9. And plus 16 divided by 4 is 4h. Okay, so that looks a little better. Alright, so now I've got, this is all under the radical sign. So under 144 plus 64, here it's the square root, and then I'm going to have 16 here, this 16 that I factored out, and what's left is 9 plus 4h. And that's going to be all over 32. Okay, so now I've got a square root of 16 that I can take out. Alright, so what does that mean? That means I'm 12 over 32 plus or minus. The square root of 16 is 4, so that's going to come out front here. And then what's left here is the 9 plus 4h. And that's all going to be over 32. Now I can simplify this. And let's see what it will look like. 12 over 32 would be 8. 4 goes into both of those, so it'll be 3 over 8 plus or minus. 4 goes into 4 once, 4 goes into 32 8 times. Oh, same denominator, and that's going to be over the square root of 9 plus 4h over 8. So that looks satisfactory. So this is one way of answering that, or 3 plus or minus the square root of 9 plus 4h all over 8. So this would be a more tidied up answer for that one. Okay, what made this challenging was we had to do the work with h in our answer, and then when we got to here, that we factored that under the radical sign, so it looked like this. Here, we need red. Okay, so I factored this under the radical sign, so it looked like this. And then I was able to reduce that fraction on the right side, simplify it. Okay, that was the first problem. The second application problem that I wanted to deal with today. Okay, we'll call this example 5. I don't see an example for this type of problem that's in your homework, so I want to go over it with you because it's a little bit mind-boggling. Alright, and this is an application problem, and it says a total of 100 meters of fencing is to be used to enclose part of a lot that borders on a river. Alright, so we've got 100 meters here of fencing, which would involve this black line. That's where the fencing is, and it totals 100 meters. And it's asking us to write an equation that gives a relationship between the length and width and the 100 meters of fencing. Alright, so what formula are they talking about when they're talking about enclosing this yard with fencing going on 3 sides? Okay, that's these 3 sides here. Alright, so we're talking about if it's fencing, it goes around the outside of the border. So there they're talking about the perimeter. Okay, so the perimeter is going to be, I'll write it up here, the standard perimeter is 2 times the length plus 2 times the width, that equals the perimeter. In this problem, however, we only have one length. Notice the other length is the bordering the river. Alright, so that I would write that. Not the top one, it would be L plus 2W. That equals the perimeter, and the perimeter in this case is 100. Write an equation that gives the relationship between the length and width and the 100 meters of fencing. So it looks like it would be something that looks like this. So it would be the length plus 2W, two of the widths, that equal the 100 what? Meters of fencing. So this is our answer for the first one. Alright, for A. For the area that is enclosed by the fencing and the river is area equals length times width, or A equals L times W. So that measures the area, where we were talking previously for this beginning part of the perimeter. Now the area of this rectangular perimeter is that the area equals the length times the width. Alright, the formula for the area that is enclosed by the fencing and the river is area equals length times width. Solve the equation in part A for length, and then use the result to write the area as a function of the width W. Okay, so let's see, here's our area formula. Area equals length times width, and they told us to solve the equation in part A for length. Alright, here's part A. If I solve this for length, that would mean I'm going to subtract 2W. And then that would give me, going this way, that the L equals 100 minus 2W. Okay? And then use the result, this is the result, to write the area as a function of the width W. Alright, well, I could also plug in, if L equals 100 minus 2W, then for this L in the formula, I could substitute it with 100 minus 2W. So therefore, the area would equal the length, which is 100 minus 2W times W. And then use the result to write the area as a function of the width W. So I think at this point I could distribute the W using the distributive property, so the area would equal 100W minus 2W squared. Alright, this is part B. C. Make a table that gives at least 7 possible values of W and associated area A. Okay, so here's the A that they're talking about, that associated area, and I want to plug in 7 values into this function, and that would be this function here. So let's see, I could use your calculator, of course. I want to first plug in 5. If 5 is here, that would be 100 times 5 minus 2 times 5 squared. Okay, now do that for each of these numbers. Using your calculator to do it, 5, let me get mine. So let's see, what do I got? 500 minus 25 times 2 is 50, so it would be 450 would be my first value. And let's see if that matches up. 450. Alright, so let's see if I can write that in with a thinner pencil maybe. So I'm going to write 450. Okay, 10 would be 800. That's an 8. That was it. Sorry about this. 15 going forward is 1,050. 20, 1,200. Wow, 25, 1,250. 30, let me break that up a little bit. 1,200. And 35 is 1,050. All right, those are filled in. And now part D is saying, from the pattern in your table shown in part C, what is the largest area that can be enclosed by the 100 meters of fencing? Well, the largest number goes from 450 to 8, 1050, 1200, 1250, and then back down to 1200. So it looks like it would be right in here. Oh, get that fat one there. 1250, because then you can see that it goes down back to 1200. From that pattern, what is the largest area that can be enclosed? 25, width of 25, and the length 25 in here would be 50. 100, here the length equals 100 minus 2 times 25, which is 50. 100 minus 50 is 50. So they're not asking this question, but the dimensions of that would be 25 times 50. The dimensions of the pen, or the area of this land,